as we move into lesson 9.3 now, we're actually still in lesson 9.2, aren't we? We're doing the last thing in lesson 9.2, the graphs of exponential functions. You're going to be able to graph them and also make a connection to, does my graph make sense? So the first thing that I want you to be doing is I want you to be reminded, I want you to underline this in it, that we have our exponential function. We know what that is. We should get that memorized. f of x, also known as y, equals a times b to the x power, where a is our what again? What does a represent in that function?
2.
No, in any exponential function, what does a represent? It doesn't always have to be 2.
Represents the y.
The starting value, when x is equal to 0. Hey! That triggers something up here. When x is equal to 0, when x is equal to 0, that means that is the it is the a value. That a value also is playing the role of
Exponent.
no, not so much. Anything to do with opposites. Okay, well let's backtrack a little bit. A is the starting amount. It is when x is equal to 0.
You got a frog in your throat?
I might. I hope it comes out. Okay, tell me where the points are that have x equal to 0. Tell me where the points are that have x equal to 0. One more time, tell me where the points are that have x equal to 0. Well, at the origin, x is equal to 0. Is that the only point on the whole coordinate plane that has an x value of 0?
Y does.
The x line does. So the x axis does? Oh my goodness, folks. Really? Oh no. You guys are leaving me next year. And I haven't really taught you anything. Maybe I should move to Florida so that, hear about how life goes after you leave. Oh, all the points on the y-axis have what? No, don't be changing my axis. I said on the y-axis. All the points on the y-axis have a 0 for
X.
x. Oh, all the points on the y-axis have a 0 for x. Can you visualize this, please? All the points on the y-axis have a value of 0 for x. What are all those points called then?
Exponents.
No, yeah, the raise, but
A function.
oh,
A value.
okay, let's go back to quadratics. I'm gonna get you again. I know I'm gonna reach you guys. Okay, so here's the quadratic function. Y equals ax squared plus bx plus c. Could you tell me what role c was
C is the
playing?
y-intercept.
Oh, and it's the y-intercept because when you put 0 in for x, what happens to the ax squared term? When you put 0 in for x, what happens to the ax squared term? Becomes 0 because 0 squared is
0.
and 0 times anything, I don't care if it's a or it's z, 0 times anything is 0. Okay, and when I put 0 into the bx term, 0 times b is, and 0 plus 0 is 0, and 0 plus c is
0.
no.
C.
C. It's C. Oh, thank goodness. It's C. So that's why C is the y-intercept. Okay, let me give you one more chance. What other role do you think A plays? What's another thing we could say? If it's the starting value,
It's what you.
the y-intercept. It's the y-intercept. Woohoo! Way to go, Julia. It is the y-intercept. So when you look at the exponential function, when you look at the a value, you can say to yourself, I bet I could go put a point on the y-axis at this number. But, you know, if you don't understand that, then maybe you should have to take the long way, okay? So, now that we've been through all that, here's the other thing we have to remember. A cannot equal 0. Because what's a times b to the x power, Calvin? What's 0, times b to the x power? 0. So a can't be 0, because then we wouldn't have our b to the x power, it'd be gone. B can't equal what?
0, 1.
1, because what happens when you have 1 raised to a power?
It's just 1.
You just keep getting 1. Is there anything going on? No, it's a flat line. Okay? And b has to be what? It can't be 1, but it has to be
Greater than 1.
whole?
No.
Oh, whole. So you said cold. Okay. It doesn't necessarily have to be a whole number. No, there's nothing that says that. It has to be
Greater than 1.
greater than, no, 0. It has to be a positive number. And so are all positive numbers whole or cold?
Yes.
You think so? No. Not so much. Okay, let's go start exploring then what happens when we work with our A's and B's. Okay? So our first function is what? In the upper left-hand corner there of our kind of like table here, we have y equals 2 times 3 to the x power. Go ahead, fill in what the a and the b value are. Fill that in, because I know you can. Okay. A is?
2.
B is?
3.
3. Okay. Well, let's just go through these and fill them all out and see then if we can start, making some, suppositions, some conjectures, some, conclusions. What's in moving clockwise? What is a value in our next one?
Negative 2.
-2. And what's our b value?
3.
3. Okay, I just want you right now, I do want to stop for just a moment, and I want you to observe something. They both have the same base, right? They both have the same b value.
Yes.
But what's different about
One
that?
is a negative a, one to the left.
One's a positive a, one's a negative a. In fact, they're exactly opposites of each other, are they not?
Yes.
Yeah. They're opposites of each other. One's positive, the other one's negative. Look at their graphs. How do you think that affected their graph? Dramatically, okay. How don't expand upon how weak or strong dramatically, but how. It appears like it flipped, didn't it? It looks like it took this, and now all of a sudden it's like this. Is that what it's doing? It flipped it over? Yeah. So when our a value was negative, and our b value was, that it stayed the same, it stays at 3, it just flipped it over what? What did it flip it over?
The x-axis.
The x-axis. Okay, go and do the other two. Go do the other two. Y equals 2 times 1/3 to the x power. Y equals -2 times 1/3 to the x power. What do they have that's the same?
1/3.
The 1/3, their b value. Okay. What do they have that's different?
A values.
Their a values again, and they are what?
Negative 2 and 2.
Okay, they're opposites of each other again. Now, now I want you to, now I need you to do a comparison between those two graphs. What happened this time? Did it flip over the x-axis again? Does it appear that's what it did? Because if it flipped over the x-axis, that would mean it should look like this. Is that how it looks?
It's more to the right.
It's more to the right?
Yeah. And it goes, it starts on the right and it goes.
Oh, you mean where it starts?
Yeah.
Both start the same spot.
Well, it's kind of like, maybe the thing that we probably should recognize the most right now is that with the A values being, one being positive, the other one being negative, we have that reflection over the x-axis. Okay, now what I want you to compare is, I want you to make a comparison between what happens when, what's the difference between when the base is greater than 1, and here the base is between 0 and 1. Because remember, it can't be 1. It has to be positive. So we got this area between 0 and 1 that gets to count, and then we have this area greater than 1 that gets to count. What happens when the base is greater than 1? Well, let's just take a look at this one right here. It's starting over here and growing up into, that's not a pen, and it's growing up into the first quadrant, isn't it? What happened when the base became between 0 and 1? Now it started higher in that second quadrant and started falling, didn't it? Okay. So let's in each of these boxes, let's make some sort of a some summaries that we think might be helpful to have. Let's do A is what here? Greater than or less than 0? Greater than. It can't be 0, so we're going to compare it to 0. A is greater than 0. Would you write that in that one right there right below it? What's the B value? Remember, the B value is going to either be between 0 and 1 because it can't be 1. It's kind of like this little cutoff. It's got to be somewhere between 0 and 1, or it's got to be greater than 1. Which one is it? Greater than 1. Here, A is what? Less than 0, the only thing it can't be. It's less than 0. How about the B value? Greater than 1. Okay, let's just finish these up and then we'll start seeing if we can make some summaries going on here. So A is what? Remember, it's got to be compared to 0 because the only thing it can't be is 0. It's greater than 0. B is?
Greater than or equal to 0.
Less than 1. He's less than 1.
So it's less than 1.
But greater than 0.
But greater than 0. Between 0 and 1. That's how we're going to have to write it. This one. A is less than, not 1, 0. The only thing A can't be is 0. And what's our B value?
Less than 1 but greater than 0.
Okay, so between 0 and 1 again. Okay. Okay, now I just want you to pay attention only to the ones where A is greater than 0. Okay, find those. Find the ones where A is greater than 0. And I want you to tell me something about what you can expect should happen when A is greater than 0. No.
If it's greater than 0, the lines are going to go into quadrant 1 and 2.
Okay, we're in quadrants 1 and 2, right? Remember, quadrants go like this. 1, 2, 3, 4. So, when A is greater than 0, it's in quadrants 1 and 2. When A is greater than 0, it's in quadrants 1 and 2. Yes?
But what happens if it's below the x-axis? It goes from 3, 4 to 1. It seems 2.
So if it's below the x-axis and it's in 1, 3, and 4?
It goes like this. It doesn't touch 2.
So it's in 3 quadrants.
Yes.
Okay. So like something like this?
Yeah.
Is that what you're saying? Okay. What do you think would cause that? You don't think it's possible? Where is it starting? Okay, we're not going to explore this type right now. We don't even know if it's possible right now. We're going to only explore the type where we have A times B to the x power. So at this point, the types we have, a times b to the x power, this should not happen. Quadrants 1, 3, and 4. Okay? We should only end up in 2 of the quadrants. So we end up in quadrants 1 and 2 when what? When what? When a is greater than 0, when it's positive. When do we end up in the other 2 quadrants, 3 and 4?
Less than 0.
When a is less than 0, now we end up down in quadrants 3 and 4. Why do you think that happened? Because of the negative. Because the a value is negative, it reflected it. It flipped it over the x-axis. Remember we talked about that, how it reflects it over the x-axis. Okay? And so what we have to, what I want you to start thinking about, and you can even just use this chart to help you. When you're done graphing, is this what should have happened? If your graph is ending up in quadrants 3 and 4, but yet you have a positive a value, that should say, something went wrong. Okay, so let's go down here and answer some of these questions. We have to respond by saying sometimes, always, or never. When sometimes, state the other possibility. So when a is negative, the graph of y equals a times b to the x power is contained entirely in quadrants 3 and 4. When a is negative, is the graph in quadrants 3 and 4? Yes, we just talked about that. These two over here on the right, when a was negative, when it's less than 0, there it was down in quadrants 3 and 4. So this would be an always, wouldn't it? Okay, how about number 2? The y-intercept of y equals a times b to the x power is a. Yeah, always. We just went through that, you guys, remember? You should have been shouting out always. A is the y-intercept. When b is a fraction, so that means it's between what and what? Between 0 and 1. When b is a fraction, it's contained entirely in quadrants 1 and 2.
Possibly.
Okay, let's go look. When b was a fraction, here was a fraction here, here was a fraction here,
Yeah,
it's contained entirely in quadrants 1 and 2.
But then the one that was negative 2, and the one that was positive.
So it's not, we can't say always for this one.
Possible.
We can't say never. We have to say sometimes. And so we would say, state the other possibility. So it is when a is what?
Negative. Positive. When a is greater than 0.
Okay, let's go look. When is it in quadrants 1 and 2? When is it in quadrants 1 and 2? When a is positive, when it's greater than 0. So when is it not? So we're supposed to find state the other possibility. We're going to say not when a is less than 0. So we need a positive a value for it to end up in quadrants 1 and 2. Okay? When is the graph of y equals ab to the x power is a straight line? Never. If it's a straight line, what would b be equal to?
0. X.
What's the thing b can't be equal to?
1.
So if b was 1, then we'd end up with 1 to a power, and that's always going to be 1, and 1 times our a value will be, we're going to end up with, we can't have a exponential function then. Okay, 5. The graph of y equals ab to the x power is contained entirely in quadrants 1 and 2 when a is positive.
Always.
Okay. A is positive. is positive here. A is positive here. A is negative. A is negative. So we can say always to this one. Okay. So when A is positive, you better have your graph up in quadrants 1 and 2. Okay? The graph of y equals ab to the x power is in all 4 quadrants.
Never.
Never. Not of our type here. Never. Okay, you answer the last one. On your own. And be ready to support it. Always?
No.
Nope. Never? Nope. Sometimes? Well, that's our only other choice. So yeah, it's sometimes. Sometimes when b is greater than 1, it's in quadrants 3 and 4. When is it in quadrants 3 and 4 when b is greater than 1? When a is what? Less than 0. So when is it not? When a is greater than 0. See over here, it's in, oh, I'm in the wrong one, aren't I? I've already forgotten what we're looking for. When b is greater than 1, it's in 3 and 4. B is greater than 1. B is greater than 1 in these two. So it's in quadrants 3 and 4 when a is less than 0. It's not in 3 and 4 when a is greater than 0 or positive. So not when a is greater than 0. Okay, now, how you're going to make the most sense out of exponential functions is you take the time to actually look through this and be like, that makes sense why this should turn out like this. Not just be able to graph them, but be able to make sense of why it turns out that way. But we need to get on to graphing so that we can be ready for homework. So they've kind of done a summary here for us of what we could expect. Isn't that nice of them? And then they've graphed an exponential function. And now we're going to go and practice our own. So here's our tables. We need to complete them. So what are we going to do? We're going to sub in the x values that were provided for us. So we're going to sub in -4 times 0.5 to the -2 power. This is where our calculator is going to be so handy. So I'm thinking that you might want to do this first, just in case you don't, your calculator doesn't like how you put it in. Maybe you should want to take the 0.5 and take it to the -2 power first. And don't forget to close that parenthesis after that 2. Negative, or 0.5 raised to the -2 power. You got to make sure you do this on your calculator, so you're going to be pretty, lost for a moment time. And then go back and multiply that times -4. And what do you get? You should get -16. If you didn't get it to happen, then you better figure out. Okay, let's try and see if we can put it all in just in the order it's given. Let's just try and see if it works. Let's go -4 times -4 times 0.5 raised to the -2 power. Did you get -16? Oh, then you can trust your calculator. Isn't that nice? And now that you know it works that way also, you can use it either way. Okay, go ahead, fill out the rest of that table. Show the substitution step first. Show the substitution step, and then the calculator gets to do all the rest for you. Okay, Julia, will you tell me what the rest of my table is? Do y'all agree with her?
Yes.
Do you see the constant ratio thing going on right here? -8 divided by -16, -4 divided by -8, -2 divided by -4. All of those are equal to 1/2. Isn't 1/2 our B value in this? And look at there, the A value is when x is equal to 0. Oh, look at there, it's -4. Okay, now that you've figured out that your calculator likes you, now the thing that is the second most trickiest thing to do is to put those on the graph in a good location. These aren't going to be so bad. Go ahead and plot those 4 points. These aren't going to be as bad as some of them will be. And the trickiest part of all is figuring out how to draw the graph. But we know what they look like now, don't we? They're not straight lines. They're not parabolas. They are curves that are either, climbing or falling. Well, this is climbing, isn't it? So you take your pencil and now you go like this and you go all the way through your graph and you never cross the x-axis. Because remember, it stays down here in quadrants 3 and 4. And now we go check it out this way. What's our A value? -4. And what's our B value? 0.5. Okay, let's go up and look. When A is negative and B is between 0 and 1, where's our graph supposed to turn out? What does it say? When A is negative, that would be one of these two. And B is between 0 and 1, that'd be this one. Huh, did we do a good job?
Yes.
Okay, we got it. Questions? Okay, go ahead and get your table filled up for the next one. This coordinate plane kind of gave it away. It's kind of pretty much showing us it better end up in quadrants 1 and 2. Okay, go start plotting your points after you have them. Here's the fun part. What's the scale on the x-axis? What's every grid line? What's it going by? No, it's not. It's going by 1. It's just that they labeled every 2. What's the y-axis going by? No? 5. So you have to somehow figure out where are you going to put ordered pair -1, 0.4. Huh. Where in the world is it going to be between 0 and 5? It's going to be it's going to be hugging the x-axis. So at x equals -1, you're going to put a point just barely above the x-axis where it can touch it. It's so close to it. And then go graph your other points. And again, you have to make good decisions about where those points should go. They can't just be haphazard. Where is 2 on the y-axis? Not just 2 grid lines up. It's 2/5 of the way between the origin and the first grid line. Gotta make good decisions about where those should go. Then after you have your 4 points, now you say, I gotta draw a curve that's only gonna be in quadrants 1 and 2, but it's gonna be hugging the x-axis. Oh dear, I didn't do a very good job. And again, we could say, you know what, A was 2, B was 5, so A is positive, B is greater than 1, A is positive, B is greater than 1. It should look something like this one. Huh, it does. Okay, let's do our last one. This one you should be able to do without your calculator. Huh. Maybe. Anybody remember what happens when we take 2 to the negative 1 power? Does that mean negative 2? No, it means a fraction. It's 1 over 2 to the positive 1 power. So it'd be 1 over 2, and half of negative 1 is negative 1/2. I bet that's what your calculator would be. Negative 0.5. After you have the points plotted, again, always look at the scales. This one looks like it's going, both of them are going by 1, so this one's, we want to make sure that we pay attention to that. I can't, my board's kind of off here, so I gotta. They're all kind of close together, aren't they? Can you tell what the behavior of it is, though?
Yep.
Do smoother curves than that, because mine aren't going very well. And again, we're going to take the time to look and see, you know what, does this make sense? I have an A value of negative 1, I have a B value of 2. A is less than 0, but greater than 1. I'm going to go up and look for that kind. A is less than 0, but greater than 1. Here's what quadrant starts in quadrant 3, falls into quadrant 4. Starts in quadrant 3, falls into quadrant 4. Okay? Okay, questions? Okay, then you have 5 of these to do, and you're going to need to, well, there is some white space, but you can kind of probably try and make your own table for the last 3. They make a table for you for the first 2. For the last 3, you can create your own table and then